Well, we've been talking about simplifying rational expressions for the last couple of days, and today we're going to be talking about solving a rational equation. Just comparing the two different ideas. To simplify means to rewrite in an equivalent form, so your end result is a rational expression. In this case, however, we're solving, and when we're solving, you'll note by the example below that we have a left-hand side and a right-hand side. We've got an equality here. And when we're solving, our final answer isn't another expression. It's actually value or values of x that worked in that particular example. I point out the differences because there are also many similarities. Some of the work that we do when solving looks a lot like the work that we do when we're simplifying. For example, we're going to consider getting a common denominator in this particular example. So let's begin by trying to get a common denominator. Now I've got three different things here. So I'm going to start with the factoring of this denominator. So I'm going to rewrite that as 3 over, this will factor into x minus 5 times x minus 2. The second fraction, well, it doesn't really look like a fraction, the number 2, but I'm going to write it as a fraction. I'm going to write it as 2 over 1. On the right-hand side, there's nothing to factor there, so I'll just recopy what I've written, which is x minus 4 over x minus 5. Now, when considering the common denominator, I really want to consider all three fractions. I have an x minus 5 that's present here and over here, so certainly that's going to be part of the common denominator. X minus 2 also going to be present because of this factor here, and then of course there's this 1, which doesn't really introduce anything new, but is certainly part of our denominators. So the common denominator in this case is x minus 5, the quantity, times x minus 2, the quantity. So what our job is going to be first is to try to clear those fractions. In this case, we're going to multiply every term by that common denominator. So I'm going to go ahead and write on the left-hand side, I'll be multiplying by x minus 5 times x minus 2. And that's all going to be over 1. Now I like to write it over 1 so it helps me to remember that these two things are both in the numerator. On the right-hand side, I have to multiply by the same thing. Whatever you do to one side of an equation, you have to do to the other. So x minus 5 times x minus 2 over here as well. Now on the left-hand side, and again over 1, on the left-hand side I'm going to be distributing this. So let's consider what happens when we distribute. On the left-hand side, we'll have, for this first term, an x minus 5 in the denominator and 1 in the numerator. Those are going to cancel. An x minus 2 in the denominator and an x minus 2 in the numerator. Those are also going to cancel. So all that will remain is the 3. For the second fraction, this 2, the only thing in the denominator here is a 1. The only thing over here in the denominator is 1, which means everything's in the numerator and nothing is going to cancel. So we'll have left the 2, the x minus 5, and the x minus 2. Nothing canceled. On the right-hand side, these x minus 5s are going to cancel. What will remain is the x minus 4 and the x minus 2. And we've immediately made this a less challenging problem because we no longer have any fractions. Now it's a matter of doing some distributing and combining like terms and solving the resulting equation. So let's go ahead and take care of that. On this part of the problem, I'm going to go ahead and FOIL this, and at the same time I'm going to distribute the 2 since I'm limited by time here. So x times x is x squared. When multiplied by 2, that will be 2x squared. We have an outside of negative 2x and an inside of negative 5x, which is negative 7x. When multiplied by 2, that will be negative 14x. We have a last of negative 5 times negative 2, which is 10, times 2, that's 20. On the right-hand side, just FOIL, we have x squared, negative 2, negative 4 for the x's. That would give us a negative 6x and a positive 8. Now I'm going to go ahead and combine. It looks like we're going to have a quadratic equation here, so I'll put everything on the left-hand side. I'll take 2x squared and subtract those x squareds. That'll give me an x squared. I have a negative 14x. I'll be adding these negative 6x's. I'll be adding 6x to both sides. That'll give me a negative 8x. I have a 3 and a 20, that's 23. I'll be subtracting these 8. That will leave me with 15. Now this is a quadratic, and I'm going to solve it by factoring, but if it didn't factor, I would certainly feel free to use the quadratic formula. This one does factor, which means our resulting answers are x equals 5 or x equals 3. Now we do have to be careful because these, although they're solutions to the original or to the quadratic, not necessarily to the original equation. If we go all the way back to the original equation, you can see that an x of 5 would make this fraction in the very beginning undefined. I'll have to reject that. It'll also make this fraction undefined, by the way. So this one cannot be an answer. I'll reject that. X equals 3 is going to work in both of those. You can always test it by substituting it back in for x in your equation and making sure that it does work, and that will be our only solution.